Okay, so today's GFG POTD is about closest neighbor in binary search tree. So the problem states that given the root of a binary search tree and a number n, find the greatest number in the binary search tree that is less than or equals to n. So we will try to solve this problem using two methods. One will be in order traversal and the second one is searching method. So let's start solving using the first method, that is in order traversal. So why we are using this in order traversal? In order traversal stores the node in a sorted order. Uh, so it follows a particular pattern, that is it stores the left node first, then the root node, and then the right node. So when it stores the data, when it stores the values in a sorted order in an array, then we can easily find out an element that is less than or equal to this n. So let's start solving this problem. So what is the leftmost node in this tree? That it is 1. We will store these values in an array. So 1, then root, that is 2, then right, that is 3. We have traversed the left subtree, so root is 5. Now we will traverse the right subtree, and in right subtree we will find out the leftmost node. So what is the leftmost node? It is 9. So 9. Now root 12. Now in the right subtree, what is the leftmost node? It is 19. So store 19. Now root, that is 21, and at last store 25, that is the right node. Now since we have stored this in an array, so we will try to traverse this from the last element to get the element lesser than or equals to this value. So is 25 less than or equals to 24? No, it is not. So continue. Now, is 21 less than 24 or is it equal to 24? Yes, it is. So just return this and you will get your desired output, that is 21. Okay, so before moving to the next method, let's code this. So we will take in vector void. Let's implement this in order traversal function. Oh, sorry, it will be in order node star root. We will check first, is the root null? Then just return it. Since we are traversing the left node first, so in order root left comma ans, then just push the root. What is given here? Okay, it's given key here. So root key, and at last move to the right node. Now we will traverse now this array to find our desired answer from the last element. If ans I less than or equals to n, then simply return our answer. Else, if there's no such element found, then return -1. Oh, sorry, it will be return ans I, since we are returning a value. Oh, ans dot push back. Yeah, we are getting correct output here. Let's submit. Okay, so all the test cases are passed. Now let's move to the next method, that is simple searching method. So we will use the concept of binary search tree here. So what does binary search tree states? It states that the left subtree will always have the nodes less than the root node, and the right subtree will always have the elements greater than the root node. So we will use this concept to find an element less than this particular value. Okay, so let's start. So we will traverse this tree until and unless we find a null value. So is 5 uh, equal to the value we are given, that is 4? Is n equals to 5? No, it is 4. So it is not equals to. So now we will move to the left node. Why we are moving to the left node? Because we want to get the node that is lesser than this value. So we will always get lesser values in the left subtree or the left child. So now is 2 less than 4? Yes, it is less than 4. So now we will check if we can find any value that is greater than 2. So to find any value that is greater than 2, we will move to the right element, that is 3. So is 3 less than 4? Yes, it is less than 4. Now we will move to the right element. Then we would get a null value, and there the loop will stop. After that, we would return this value, that is 3. Okay, so let's implement the code now. Int ans equals to -1. So now while root not equals to null, just move forward. Then if my root equals to n, then just return the root y to move forward. Then check for n is greater than root key. Then store the answer here. Then root equals to root right, and after else move to the left. At last return ans. Okay, so it's compiled. Now let's submit the code. Yes, so all the test cases have passed. So let's end the video here only. So if you like the video, then please hit the like button and the subscribe button. And if you have any queries regarding this video, or if you want to share your thoughts, then please share your comments in the comment section. Thanks for watching.